Hello, this video will explain you about the basic terminologies used in PCB design. If you are a beginner and you want to make a PCB your own for your hobby circuit, I will explain how to create a PCB in Proteus. Before that, you must know some basic terms used in PCB design. So let's begin. I don't want to explain what PCB and what it does because you already know that. That's the reason why you are creating PCB. You can see the figure of a PCB here. I will explain basic things you want to know what a PCB included from this figure. You can see markings over here are C13, R31, pin configuration and other detail. Using a white ink on the top of the PCB, that layer is called silk layer. It can be on the top of the PCB or bottom of the PCB as shown the figure. And next thing you want to know is what is a pad. Pad is a place where we place a component. That means this yellow place is a pad where we can drill a hole and place a component, or you can also place a SMD or surface mount device over there. Okay, there you can see a rectangular pad and a oval pad over here. Also, one thing you want to consider is that while you are making a hobby circuit, most probably you are making a single layer PCB. There are also multi-layer PCB which can be designed using Proteus. So you must know the basic term size or the measurement unit used in PCB design. PCB design in Proteus is usually done in the unit of toe. One toe is 1/1000 of an inch. That means 0.001 inch. This is also called as mils. You can also set basic settings to millimeter range. I explained pads already. You can see the examples of pads here, oval shape and other shaped pads. Next is copper track. When we design a PCB, we must set the width of the copper track, and it must be done manually, because if you did it automatically in Proteus, it will give very thin copper tracks that will be difficult after etching process. And if you know track and pad, you must also be familiar with the word vias. Vias stand for vertical interconnect access. That means it is simply similar to that of a pad, but it is used to interconnect different layers in a multi-layer PCB. You can see example here. This is a multi-layer PCB. Each color denotes each layer. Top layer is connected to the bottom blue layer using a vertical component. That component or that part of this PCB is called via. Using via, we can interconnect the layers, while pad is for connecting components to the PCB. To create a project, click on New Project tab on the Proteus. In the project wizard at the startup, you can rename your project as you like. Then click Next. If it shows do not create schematic, change is to create a schematic from the selected template, and the selected templates must be default. The same thing we done for schematic must be done here too. If you are creating some kind of firmware project like 8051 based or ARM based or PIC based or DSP based, you can select any one of the family of the microcontroller processor you are using here. If you are not using any kind of firmware or simple circuits, you can choose the option no firmware project. Click Next. On this screen, you must click Finish. Once you're done with creating a project, you will meet a screen like this. In a project, you have two screens, one for PCB layout design and other for schematic capture. First of all, you want to create a schematic for your circuit. This is the workspace. You can see the workspace here in the blue box here. There are two modes available on this schematic capture and also in the PCB layout. That is component mode and component mode you can see here, and the selection mode. Using selection mode, you can select drag or drop where the components you created or change its properties, etc. On component mode, you can pick components from the library. To pick component from the library, click on the P tab here. This will get you to the Proteus library. You can type any component name you want here, or you can also find out manually from this list. Once you selected a component, you can see its pinout and its PCB preview, or its preference and its dimensions. So you select the component you want and you can place it over anywhere as you like. Once you place the component, you can rotate it by selecting the component, pressing plus or minus keys on your number pad to rotate it clockwise and anti-clockwise. You can also flip the component in X mirror or Y mirror, mirror the component. Then you can see the labels here, U1 and its the name details here. You can also change it. To change the labels of a component, zoom in and select the text. When you select the text, it will be in a red box, so you can double click and you can change the name to IC1 or as you like. Also you can hide the component text over here. For that you must select it and press Ctrl E or right click and go to edit properties. Here you can make the part value to hidden or the part reference to hidden. So I am currently hiding the part value, so I am taking hidden over here when pressing OK, and now you can see the part value of this IC. Let's place another component. So I am placing a 4017 decade counter. Now let's connect this pins of this IC together. To connect or draw a wire on Proteus, go to the end of the component terminal and press left mouse button. Then you can see the wire dragging over as you move your mouse. You can also bend this wire at a point. So if you want to bend this wire at a point here, I can press left mouse button when I reach that point. Now the wire is bent over here, or I can drag it down. Again I bend it and I completed the wiring. Like this you can complete all your connections. I am just making a scratch circuit for my demonstration purpose. Try to avoid overlap of these wires as I shown here. This will later cause big trouble while we are designing PCB for this drone circuit. Okay. Now one thing you can notice here is that we want to place VCC and ground power lights. For this a 555 analog IC it is so easy because this ground pin and VCC pins are visible, while for the digital IC it is not. So if you met such cases, then you must go to terminal mode, is another mode available on Proteus, and go and press on power grid and place a power grid over here and a ground terminal over here, and select the digital IC and go right click and go to packaging tools. Here you can see that VDD and VSS pin are hidden because it is ticked over here. You can see hidden pins, that's 16 and 18. As per the pin out of this 4017 IC, 16th pin must be connected to positive rail and 8th pin must be connected to ground rail or 0 volt or negative rail as shown here. So 16th pin to VDD and 8th pin to VSS, since VDD stand for positive rail and VSS stand for ground rail. Okay, so I am just renaming this power rail to VDD, then pressing OK. Also renaming this power ground rail to VDD. You must double click to add a string label to that power rail. So I am double click and change it to VSS. Once you've done this, the Proteus will automatically reroute VCC pin to the 16th pin of this 4017 IC and ground to 8th pin of this 4017 IC in the PCB layout designing. You don't want to be bothered about that anymore. For this 555 IC, you must done it manually. Once you finish your circuit and schematic, you can go to PCB layout as shown here. Or if you don't have a PCB layout here, press on Aries to get a PCB layout. This is the PCB layout design or Proteus Aries, where you design and calibrate the precision, length and measurement for your PCB and route your PCB to get a PCB layout. Any component you selected on the schematic capture will automatically netlisted on this component mode in the Proteus Aries. And the same selection mode and components mode is available for PCB layout here. Before placing the component, you must know the basic unit measurement used here. Normally the default measurement you can see on the right side here when I move the mouse over this black screen is toe or 1 by 1000 of an inch, as I explained earlier in my video. So using toe is much more difficult, so you must convert it to mm as basic unit. To convert toe to millimeter as basic unit, press M on your keyboard. Press M on your keyboard. Once you press M on your keyboard, all your unit or measurement will be in millimeter. You can see it on the right side of this here. And first thing you want to do is set DRC rules for your PCB. So go to Technology tab and press on Design rule. Here you can see pad clearance, pad trace clearance and plate trace clearance. For a manually made PCB, you must set this pad trace clearance to 25th and trace clearance to 25 too, because if you put the default value of pad trace clearance and trace clearance to 10th row, it will be too small, and normally you know that a handmade PCB can be contain so much error, so it will be so difficult for you to fetch out sometimes. Pad trace clearance must be in 25 or 25 tau, each of 25 mils. Then go to net classes. Here you can see two modes, power and signal. First select power mode and change this layer to bottom copper. Also go to signal mode and change this layer to bottom copper. Once you are in a signal mode, change the trace tail to 2050. 25th trace tail means the width of your tracks, copper tracks, and also in power mode change the trace tail to 25th. Now you are almost done. Then press OK. You can change the layer visibility, what kind of layer you want to see, by going to the top layer and edit layer color visibility here. Here you can tick mark every one of them or what layer you want to see. So if I press all layer will be seen. If I press none, no layer will be seen. So basically for a single layer PCB, bottom layer, top silk and bottom silk are necessary for our project work, and you also take its border edge for your PCB always. Next is to draw border edge for your PCB. To draw a border edge for your PCB, go to 2D graphics mode on the left side tab and press 2D graphics mode. Select the layer to top select from to border edge. Once you select the border edge, you are switching to basic unit mode to mm. Go to the center of this screen and just draw by left clicking and dragging. Your board measurement can be seen on the rightmost bottom corner. You must be thorough with how much size your board should have. Once you get the desired measurement, you just click the leftmost button once again to terminate. You can also resize the board size later. To resize the board size, you must go to the selection mode and click on the board edge. You can see this green pickups lines, so you can resize or free transform it to size as you like. Then go to component mode. Here you can place the component manually or by auto placer. So if you place the component manually, go to component mode, click the component and place it over here. Or we can also auto place this component by tools auto placer. Once you place your component and set the DRC rule, you can go to auto router and start begin routing. The Proteus will automatically route all components here. The blue line indicates the bottom layer. If you are using a two-sided PCB, you will get a red line denoting a top copper layer. For this hobby circuit, this will be sufficient for you. Also, always keep in mind that auto router is usually used for creating two-layer PCB. Once you finish making your PCB layout, you can also have an option for 3D viewing in this Proteus. Go to 3D visualizer mode here. Now you can see how my PCB look in the real world. You can drag over here and view the back side as you wish. You can also go to top view, bottom view and a kind of views here. So 3D visualizer will be helpful how your PCB look on the real world. Next is we are going to print this PCB layout to using a printer or export this as a PDF. Currently I don't have any printer, so once you want to print this PCB layout, go to output and press print layout and other printer information printer set. You can do it manually, so easy. Or you want to export it as a bitmap file or an Adobe PDF file, you could export graphics. And now I am creating an Adobe PDF file. Go to export graphics as export as Adobe PDF file. While if you are making a handmade PCB, you don't need this board top copper layer, top silk layer and make one layer. You only need border edge and bottom copper layer for a single layer PCB. Never mark these two boxes. It will give you the whole PCB layout, which is not useful for while etching. So you only want the bottom side of this PCB. Once you're done with that, you can press OK. Now you see the PCB layout. Here no top silk layer is available, only the PCB layout. If you want to know how to etch the PCB, all details are given on my video. You can check out my channel for that. Thanks for watching. Don't forget to subscribe and like.